Okay, so yeah, hi, I'm Meijke, and I wanted to talk a little about robust NLP, natural language processing. It's an interesting topic that I was investigating with Hobson over the past few months. So let me explain the problem a little bit. Is we know about these natural language processing models that can do all these cool kind of classification and translation tasks. So one kind of task that I looked into is called inference. It's where you have a premise and a hypothesis. And you want to say if if those two are entailed or they contradict each other, or if it's just neutral. Um, so the state of the art is actually around 90% if you uh, have these really large, transformers that um, can usually get around 90% on these standard data sets. Well, it sounds impressive, but the problem is that it's not really robust. But then you can very slightly change, one of these words. And so, for example, you change young to useful, and all of a sudden it changes its mind. So you might have seen something like this in the domain of images, but so it's the same kind of thing in natural language processing. And a little bit more about what I mean by brittle natural language processing as opposed to robust is that it's not invariant under these kind of semantic preserving transformations. So if you say something one way and then say the same thing another way, obviously you want your machine learning model to uh, give the same result, but often it doesn't. So what they actually do is use like these heuristics that tend to fail, and they're very bad at like basic propositional logic. So like uh, negating things or conditionals. And so an example of this is the Hans data set. It's actually a subset of one of the more common data sets, but um, it identifies these examples where these models get very low um, accuracy. So here's like an example. So it seems very simple, but a surprisingly large number of models will fail on this. So yeah. And so one thing I looked into is how can we try to train robust models? So the first problem you have to solve is actually augmenting the language data. And it turns out that this itself is a really hard problem. It's a lot harder than doing it with an image because there are a lot of things you have to preserve. So you have to preserve the grammar, the meaning, and also, the relationships between the sentences. So, a kind of picture you might have seen is like this one for images, where you can add like very small continuous perturbation and get the model to change its classification. But you can't really do this with sentences since the space of words is like discrete space, not a continuous space. So, and here are some current approaches, and I'm going to show a couple cool Python libraries that can do these. So the current approach is basically you just identify the most important words to the model, and you just look at the gradient or something, and then you just substitute them with synonyms. So it's kind of a naive approach, but it's kind of the best one we have right now. So once you pick the words you want to substitute, you can do it in a bunch of different ways. So you could just literally like look up synonyms in a thesaurus, or you can use word embeddings, or use another language model to pick out words. So here's an example. It picks out these two words as important and then changes them to synonyms, and then this actually fools the model. And another one I wanted to mention was, so since the current approaches like this aren't actually very good, another approach is just to get humans to generate the data for you. So this is a data set collected by Facebook where humans actually try to fool the models. So you can check that one out. And here are two libraries that do text augmentation, like I just explained. So one is text attack, and it has a command line interface and also a Python API. So yeah, here's an example of how you could use the command line interface. So it allows you to attack a bunch of different pre-trained models. So all the models on Hugging Face you can access. And then it has all these things it calls recipes, which are just implementations of algorithms from different papers. And it's a pretty mature library. And the cool thing is you can easily create custom attacks on these models. So for example, you can basically choose from a bunch of different transformations and then put some constraints on how much you want to change the sentence around. And then you can also specify how you want to search through the space of all these sentences, and then choose which model you want to target. Or you can just do this on a data set. And one other one is called Open Attack. It's I haven't used it as much, and it's newer, but so it's pretty similar, and it has pretty much all the same algorithms, but it has a few extra ones. And I gather it has good support for Chinese models. So yeah, I'm not sure how much time I took, but thank you all for listening, and special thanks to Hopsin, Tangible AI, and of course the Python users group.